Hey guys, today's lesson is going to be about special right triangles. Before we get started with special right triangles, I do want to refresh your memory on how to simplify radicals completely, which usually involves rationalizing a denominator, especially in the special right triangles bit here. So we'll take a look at these. Let me switch colors and we'll get started. When you have the square root of 7 on the bottom, this is like an improper fraction. It's more or less like someone in English class saying, I is not doing nothing good. And you're like, well, are they doing something good or bad? You're like, I don't know. Because it's improper and it's really hard to sort out what's going on. And there's a couple of wrong things in that sentence anyway, but it's really just hard to understand. And in mathematics, it's kind of, that's not necessarily hard to understand, but it's still improper to have this square root at the bottom. At least in America it is. So what we do is we actually change this around. We say the square root of 7 is what is actually giving us the problem. So what we'll do is we'll multiply by a special form of 1. Whenever you multiply something by 1, it remains the same, but may take on a different form. So what happens here is we'll multiply by the special form of 1, which is the square root of 7 over the square root of 7. What that does when we multiply fractions across is we'll have square root of 7 on top. Square root of 7 times the square root of 7 is the square root of 49, or just 7. In this case, these two, what we started with, and this final thing that I just circled, are actually equivalent. They're actually equivalent statements. They mean the same thing, and if you put it in the calculator, they'll give you the exact same answer back. But the difference is this does not have a square root on the bottom, so it's fine. Same thing happens over here. There's probably a couple different ways we could simplify this, but just for sake of learning, we'll just say that you just recognize that the square root of 3 is the problem. The 4 is not a problem. The square root of 6 on top is not a problem, but the square root of 3 is. So we'll multiply again by the special form of 1, the SFO, which looks like this. We'll multiply across. That'll be 4 times the square root of 18. Remember, you just multiply radical by the radical. Leave the coefficient by itself. Square root of 3 times square root of 3 is the square root of 9, or just 3. And I'm not done yet. I can't simply cross out this 18 and the 3, but you can't do that. Do not do that. What you can do is this 18 can still be broken down into 9 and 2. This is 3 and 3 if you remember. So we would have 4 times 3 on the outside times the square root of 2. And that's going to be all over 3. I'm not quite done yet. I can either multiply these together and get 12, or if I notice there's a 3 on top and a 3 on bottom, I would be left with 4 times the square root of 2. Okay, kind of a shortcut if you notice this. You could take, and since these are both on the inside of a square root, you can just kind of make that a 2. You'd have 4 times the square root of 2 and jump over all that. That doesn't really help me when I'm talking about rationalizing denominators, which is really what I want to talk about. And number 3, again, there's kind of an easy shortcut with it. Bear with me. There, you could divide this 12 and 3 and have a much simpler answer here, but what I want to do is I just want to make a point with this. The 12 in this is not a problem. You can definitely have a 12 on top. You can definitely have a 3 on the bottom. That's not a problem. What the problem is when we have the square root of 2. So we'll multiply by the square root of 2 over the square root of 2. This is our special form of 1. A lot of teachers will just tell you, maybe because they don't know better, or maybe because it's just easier for them to tell you, to multiply by the entire denominator. That is not necessary. The only thing that's a problem is the square root of 2. So we'll multiply by the square root of 2. So it'll give us 12 times the square root of 2 on top, and 3 times 2 on the bottom, which is 6. At that point, 6 and 12 can simplify, and I'll just have 2 times the square root of 2. That's how we rationalize denominators. In case there's something that we don't like on the bottom, such as square root of 7, square root of 3, or square root of 2. If you need more, I've made some videos on rationalizing denominators. You guys can check those out. On to special right triangles. What happens is in mathematics, there's kind of a couple neat things that happen. If you're given a square and all of a sudden you're cutting through it with a diagonal, what happens is this 90-degree angle is actually bisected, and you have a 45-degree angle here, another 45-degree angle down here, and you have a right angle here. What's interesting about this is that with this shape, let me see if I can draw it over here again. With this shape, we know that it's a square, that these two side lengths are going to be the same, like 8 and 8. And we can use the Pythagorean theorem to find this C, or this hypotenuse, I guess, in here. And C would just equal 8 times the square root of 2. Well, you do this enough times, and you'll notice that in a 45, 45, 90 triangle, that's all you're really doing, is that you're just going to be multiplying this by the square root of 2. So whatever this leg is, whatever this side length is, you're just going to multiply by the square root of 2. And that's what this first theorem talks about. So in a 45, 45, 90 triangle, the hypotenuse is always the square root of 2 times as long as the leg. So in other words, if we have a formula and we're looking for the hypotenuse, we would just take whatever the side length is, and we're going to multiply it by the square root of 2. Similarly, if we're looking for the side length and are given the hypotenuse, we'll take the hypotenuse and divide it by the square root of 2. So depending on what we're given, we'll either multiply by the square root of 2 or divide by the square root of 2. And in many cases, we'll have to rationalize this denominator, but not all of them. So there's two formulas. A very similar thing happens with 30, 60, 90 triangles. They're formed by dividing an equilateral triangle in half. So not a square, but an equilateral triangle in half. Generally speaking, that would look something like this. And it's divided in half, and this becomes 30, this is 60, and this is the 90-degree angle. Okay, what happens is there's more formulas that are formed. Instead of using the square root of 2, there's a square root of 3 involved. So the idea is you really want to have this part here. The way we talk about this is going to be the hypotenuse. This is going to be the long leg, and this part over here is going to be the short leg. So short leg, long leg, hypotenuse. If you don't know something, or if you want to find just one piece, always find the short leg. That's the piece that you really want. All the formulas can be driven just from the short leg itself. So here we go. If we have the short leg, you can multiply it by 2, and that'll give you your hypotenuse. Hypotenuse equals twice the short leg. Your long leg is always your short leg times the square root of 3. Similarly, you can reverse these. If you want to find the short leg, you have the hypotenuse. Just take the hypotenuse and divide it by 2. If you have the long leg and want to find the hypotenuse, we'll simply take the long leg and we'll divide it by the square root of 3. Oh man, there it is. Divide by the square root of 3. So these four formulas help us with 30, 60, 90 triangles. These two formulas help us with 45, 45, 90s. Okay, it says find the value of each variable. Write your answers in simplest radical form. When we go through this, some of these are really easy to see, and some of them may require a formula. If you do need to show all your work, you'll identify that the short leg here, or the side length, equals 12. Your hypotenuse is going to be equal to the side length times the square root of 2. We'll just substitute this in. This would be 12 times the square root of 2. And usually it's a good idea to use the variables instead of h, which it is the hypotenuse, to actually use the variable that they gave us. So x equals 12 times the square root of 2. I'm going to skip this one. I'm going to just do the 45, 45, 90s first. Since this is 45, 45, and 90, I know that this side and this side are technically the same. But this time I'm given the hypotenuse. So I can say the hypotenuse equals 9 over the square root of 2. I know the short leg, or the side length, I guess, is equal to the hypotenuse divided by the square root of 2. So if I have 9 divided by the square root of 2 divided by the square root of 2, what's going to happen is, I'm sorry, I totally wrote this wrong. Let me erase this. Let me just try this one more time here. Here we go. I'll use green again. If I know that my hypotenuse equals 9 times the square root of 2, my short leg is equal to the hypotenuse divided by the square root of 2. So when I substitute this in, this is 9 square root of 2 divided by the square root of 2. These guys cancel. And my short leg, or x, just equals 9. In this case, 6 is here. I mean, 6 is going to be up here. This is just going to be 6 times the square root of 2 because it's my hypotenuse. Very similar to this first problem here. In this problem, again, this is a 30, 60, 90 triangle. If you needed to, you could find this length here. With a 30, 60, 90 triangle, again, you really want to find this piece here. What we're given is we're given the long leg. The long leg equals 13 times the square root of 3. So your short leg is always going to equal the long divided by the square root of 3. Or in this case, that's 13 square root of 3 divided by the square root of 3, which equals 13. So that's our x value. Our y value is just, that's our hypotenuse. Hypotenuse equals 2 times the short leg. So that's going to be 2 times 13, which equals 26, which equals our y value. I want to change around this problem here. I'm actually going to switch it so that the 8 is here and the y is here. I just think this makes for a much more interesting problem. Why don't you guys take a minute, and why don't you guys try these two examples really quickly. Okay, welcome back. Hopefully you got some answers. Let's just compare them really quickly. I would say my side length equals 5 times the square root of 3. I'd say that then the long leg equals this short leg, 5 times the square root of 3 times the square root of 3. So in that case, that equals 5 times 3, which is 15, which is my y value. For my hypotenuse is always going to be 2 times 5 times the square root of 3. Remember, when you multiply this, you just multiply the 5 times the 2. So it would give me 10 times the square root of 3. And that's going to be my x value. So I'll just circle this. You don't always have to do these in alphabetical order. You can kind of do them in whichever order you really feel like. Most of the time, if you're given this short leg, you can go in either order, honestly. This one's a little bit more complicated. It says that our long leg equals 8. It just doesn't seem like it's a big problem at all. Just that our short leg is always going to equal our long leg divided by the square root of 3. And that looks like this. Okay, we can't leave it like that. Again, we in America have to simplify these by rationalizing the denominator. So that would give me 8 times the square root of 3 over 3. I can't really simplify that any further, so I'll just leave that as my x value. My y is going to be the hypotenuse. Hypotenuse is always going to equal 2 times the short leg. Well, in this case, that's 2 times 8 square root of 3 over 3. Again, when you multiply a coefficient by this, all you do is you multiply basically the numerator, the coefficient of the numerator. So I would have 16 square root of 3 over 3. Since I can't simplify the 16 and the 3, that's going to be my answer. That's going to be my y value. In these problems, this is just using the formulas that we've talked about. Many of these are really easy, just a few of them require a little bit of work. This guy right here requires just a little bit of thinking. This one requires a little bit of thinking. I think these are the two really challenging ones. The rest of them are pretty straightforward. If we're given x is going to be our side length. So we'll just say this is going to be 5 times the square root of 2. If they give us 4 square root of 2, we just divide by the square root of 2, which gives us 4. If they give us 9, this is just going to be 9 times the square root of 2. This guy, remember that in order to get down here, you multiply by the square root of 2. So you'd have square root of 2 times the square root of 2, which is just 2. This last one here, we basically are going to have to take 24 and divide it by the square root of 2. We have to rationalize our denominator, so we multiply by the special form of 1, which is 24 square root of 2 over 2. At that point, we can simplify these two guys, and we come up with an answer of 12 times the square root of 2. Okay, let's forget those rules for just a minute, and let's look at this 30, 60, 90 triangle. In this case, A is our short leg. This is what we really like. B is going to be our long leg, which means we just multiply it by the square root of 3. And this is our hypotenuse, which means we just multiply A by 2. So it's really good if we have this 9 and this 11. Those are really good. We can just come down here and say this is 9 times the square root of 3. And we could say this is 18. 11 is really easy. We just say 11 times the square root of 3. And then we double 11. That gives us 22. This one's not so bad because if we have 16, we just half it, or divide it by 2. And we get 8, then this becomes 8 times the square root of 3. It's not too bad if you've seen these rules before. You can kind of just jump through them. If I'm going too fast, maybe go back to those rules, just refresh yourself on them. This guy's not so bad either because in order to get to the top, in order to get the short leg, the part that we always really want is the short leg. All we do is we divide this number by the square root of 3, which gives us 5. To get to the bottom, we just multiply by 2, so that gives us 10. This guy's a little bit more complicated. I have to take 9. In order to get to the top, the short leg, I have to divide by the square root of 3. So in order to do this, oops, I don't need to equal it. I need to multiply by the special form of 1, which would give me 9 square root of 3 over 3. At that point, I need to simplify it just one step further. I should get 3 times the square root of 3. When I double that, that's 6 times the square root of 3. These bottom answers, problems aren't so bad. It says find the value of each variable, write your answer in the simplest radical form. This is one thing that we're really stressing is how to rationalize and how to write these in the simplest form possible. This looks to me like it's going to be a 45, 45, 90 triangle just because of these two pieces. So if this is 10, I think S is 10, and R is going to be 10 times the square root of 2. In number 16, because this is N and this is 2N, I would assume that N equals 30. That means 2N is going to get 60, so that's a 30, 60, 90 triangle for sure. The short side is always across from the smaller angle, so that's P. So I'm given this is my hypotenuse, this is my short leg, this is my long leg. So the short leg is always half of whatever the hypotenuse is, so P is going to equal 15, which means Q equals 15 times the square root of 3. In this case, this looks to me, if these are both the same, that means they're both 45, so x equals 45. If this is my side length, this just becomes 12 times the square root of 2. We have a roofing problem, kind of an interesting deal. I want to add a little extra piece to this. I'm going to say part C. It says that maybe if the cost of maybe the specific type of like shingle, I guess, or whatever you want to put on your roof, is going to cost $3.87 per square foot. How much would it cost, I guess? Would it cost if, let's see, if this, how much would it cost if you want, just in case you need something, you need about 10% extra for the I guess shingling it. So you're going to buy everything that you need, and you also want a little, about 10% extra. How much is it going to cost all the way? So here's what's going on. You're replacing the roof of your house. As shown, you want to know the total area of the roof. The roof has a 1-to-1 pitch. That's kind of interesting on both sides, which means the slopes upward at the rate of 1 vertical unit for 1 horizontal unit. What that basically means is we have a 45-45-90 triangle going on right here. Okay? Find the values of x and y. So if I was to draw this really quickly, here's my triangle. This is 45-45-90, isosceles triangle. This says this is 24, so that means this base is going to be 24. Which means all I have to do is take the 24 and divide it by the square root of 2. And I think we just did this in the last problem, so we'll have 12 times the square root of 2. So both x and y equal 12 times the square root of 2. Part B, I guess these are feet. So if you really want that, that's a feet. Part B says find the total area of the roof to the nearest foot. So what happens is we see part of this, it goes like this, and we'll need to find this part of the roof. And then also there's probably one on the other side, so we'll basically have to double this. So in this case, area is going to equal 35, because that's the base of this rectangle. 35 times 12 square root of 2. And we're actually going to take and multiply this by 2, because there's this sort of the right side, and there's also like a left side over here. There's a roof part over here. So there's one side here, and the second side's on the left side. When we multiply this out, the exact answer, which we probably don't want, is 840 times the square root of 2. To the nearest foot, when we calculate this, that's 1188 square feet. So that's the answer to part B. I extended this problem with part C and said, let's take and multiply this. 1187 times $3.87. Let's just see what the bill would be if we don't want any extra. In my calculator, that looks like $4,597.56. Now, if I want 10% extra, that means I want all of this. That would be 100%. Then I want 10% extra. So I want 100 plus the 10%. So I'm going to multiply this by 1.1, which is equivalent to 110%. So it's 100% of it plus another 10% on there. When I multiply it that way, I get to the nearest penny this way, I get $5,057.32. That gives you a good idea of how much this might cost if you're going to do the job yourself, as opposed to hiring somebody else for materials anyway.